midpoints. So let's finish our notes on 1-3 here today, and we'll go on from there. All right? So we've mentioned this a little bit before when we talk about this thing called congruency. Congruent has a symbol. That symbol stands for congruent. Congruent is just another fancy way of saying things of equal measurement. What happens here is that we use congruency for talking about segment lengths. We talk about congruency in terms of angles. We'll talk about congruency in terms of side lengths, things like that. So when you see the word congruent, it just means that they have the exact same value. Does that make sense? The example that we had yesterday where we had the 4 points, we had those 4 points, and it said that, I forgot, let's just say it's W. I don't remember what the numbers were. We'll say that's what they were. What happens here, thank you. What happens here is that if we say that Wx is congruent to xy, when we say that happens, that's when you do this to diagrams. That's when you will see this quick little tick mark. That tick mark denotes that those two values are going to be the same. That's when we say that those guys are congruent, if you will. They will have equal measure. Yesterday, that quick example we had with the 4 points being collinear, I think it said that Wy was equal to 18. And that's why we were able to say that both Wx and xy were both equal to what? If two things are the same, they add up to equal 18, what does each piece have to be? 9! Very good! And that's what we were able to do there. They have equal value, equal measurement. All right. What's that? Oh, all you need to worry about? Oops, sorry. Never mind. So segments that are equal length are called congruent. Because it could be segments equal length, angles equal degrees, anything along those lines. If they have equal value, they are congruent to one another. It's just a fancier way of saying equals. Does that make sense? Yes. All right. Now, the second part of what we needed to get through today was that idea of what's called a midpoint. You could probably figure out what a midpoint is without even thinking. Josh. Why don't you come on up front here today, all right? That way we can focus a bit better. Please. Thank you. Come on. Yeah, come on.
Only I can do it.
No.
I'm allergic to the front of the class.
Josh, enough. Thank you, sir. Grab a piece of paper. We're not going to be turning around talking with everybody today. We're going to sit here and try and focus and write some stuff down. That's what we need to work on. That's what we're going to do. So when we start going into this whole idea of what's called a midpoint. Midpoints also have this really weird, long drawn out definition, when actually it's something super easy. If you can take, let me see if I can make this easier on this. If I want to take what's called a midpoint, obviously abbreviations happen all the time. MDPT, midpoint, you okay with that? Because, writing out the word midpoint is too many letters. I know, I'm sorry. What happens here is a midpoint. A midpoint is the halfway part of a segment. It cuts a segment into two equal segments. It's anything that cuts a segment into two congruent parts. I'm going to use the word congruent because when we're talking about lengths, we're talking about the value. If you wind up with two equal values, that means those two things would be congruent. Okay? That's where that terminology comes from. Now, I use the thing as anything that cuts a segment. Sometimes it's an actual point. Sometimes it's a segment. Sometimes it's a line going through it. It could be anything. I think on that question that you had on the homework, it looked like it was another segment that went through it, kind of like that. It could be that as well. What the midpoint does is that it creates two equal parts. Right. If we put this in terms of words, let's say this: A, B, and C. I'm going to show you. Have you guys ever heard of an if-then statement?
Yeah.
What is it?
If something, then something else will happen.
Perfect. That's exactly what it is. Now, what happens here is that these, what we call if-then statements, we use them quite a bit in geometry to help show progression, to show next steps of stop sign. See the stop sign? I'm going to stop sign. Take a look at you guys, all right? I'm going to.
That's one wake up call.
You gotta know where I'm at, right? Oh, you got that one? I got a pen. You grab a pen. That one. We're in the same class. We should do the same class. I want to do the other. Keys. I'll make sure I got my keys. And I'll be able to.
That was the worst.
Fire dryer ever.
I want to go home. I wish this thing would burn down. I mean, like, we already got the fire alarms on. Why would you burn the thing? That's how you yeah, buddy.
Is that all right? No, I'm taking off mine. Yeah, let's go open the other door.
Loading it
Look on the side.
makes my day.
Now just remember, children,
Great.
golf by flame, run and scream. It's more fun from here.
Oh, hey. All right. So anyway, like I was saying, is that a lot of times in geometry, what's going on?
Nothing.
A lot of times in geometry. Thank you, sir. A lot of times in geometry, what we do is we write things into those if-then statements. And when we do that, we are going to utilize them later on into what we call some very simplistic proofs. I like to think of it as a progression. If you know one thing, then what can you say about it? Well, in this case, we know that we have a midpoint. So if I write it as if B is a midpoint of AC. I'm going to write it out in nice long form here, real easy. If B is the midpoint of AC, then by definition, what are the two segments that are created that are equal to each other or congruent to each other?
AC. A and B.
AB and DC. So then I can say this, then AB is congruent to DC. Is it the end of the world as we get into some of these things if we don't put the little bars over segments?
No.
It really isn't.
Okay.
In the grand scheme of things,
All right.
I mean, really, if you get into it, if you understand what a midpoint is and you can write that all out,
It's good.
that's great.
Okay.
The actual super fancy nomenclature, if it isn't perfect, this isn't college, I'm not worried about it. Okay? That's what we write as far as what's called a progression, if you will. You will see this again later on when we start to do a little bit of proof things. What I mean by that is we're able to use definitions and theorems and stuff to show how things interrelate. This is the very first one that we look at. Yes, ma'am.
What is that squiggle?
The swiggle? Oh, this is what this means. This is equals.
Okay.
This is congruent. Congruent is just a fancier way of saying equal.
So
You know what that squiggle is called?
Double equal.
Tilde. Knowledge, yes, it's called knowledge. Yeah, it's an equal with a tilde.
Okay.
All right. Yeah, it's just a fancier way of writing, fancier way of writing. Not so bad.
No.
All right. So let's look back then. I think they have the example here. Nope. Q is the midpoint
Well, then plus one.
Wow.
So right away, I'm just going to skip the examples with numerical value and show you an example with what you have to do in terms of solving for x or setting up an equation along those lines. Okay? Do you need paper? I got plenty of it.
I got something on the way.
I have some dream purposes.
So by using the definition of midpoint, just like we said a second ago, that whole idea of the if-then statement, since Q is my midpoint, what are my two segments that have to be equal to each other?
PQ and QR.
All right, so then I can say this, PQ is congruent to QR. Okay?
Whoa.
Yes, sir.
Check the homework.
Yeah, we talked about it at the beginning of the class.
I did it.
That's fine, cool. We'll talk about it. I'm going to add to it tonight. So what we have here then is PQ has to be congruent to QR. Now, just like Ms. Pringle was saying,
Shine.
shy. That's right. It's like Shai was saying was that when you have that fancy congruent symbol, it means the same thing as equality. So that means that, well, what is the value of PQ in our example? 6x minus 7. And what's the other one? 5x plus 1.
X5 plus 1.
S.
What's that?
That's an
That's an
S.
S.
You'll have to squint.
That's a sugar.
So what happens then is that you are able to set up an equation to solve this. By using the definition of a midpoint, you know what two segments have to be equal to each other, and you just fill in the blanks. So in this case here, we've got variables on both sides of the equation. Remember the rule for variables on both sides of the equation?
That is, I don't know.
You pick on the little guy. Which one's smaller, the 5 or the 6?
The 6. The 5.
Shh, ladies and gentlemen. Subtract the 5x from both sides.
There's going to be X minus 6.
X minus 7 is 1. And then how do you move the negative 7?
I thought it would be X minus 6.
You add the 7. And there you go. That gives you the value of x. Okay? Yes, sir.
I thought it would be X minus 6. Because it's like a plus 1.
Nope. Remember, when you have variables on both sides of the equation like this, you have to move your ones with the variables first.
Yeah.
So then when you move, which one's smaller, a 5x or a 6x?
5.
That's why I subtracted that over. And then you get 6x minus 5x is 1x. Just bring everything else down. How do you move a negative? You add it. That's all we do. So now that gives me values of x is at 8. Well, what do we do with that then? Okay. We take those values of x and we substitute back into here and here. Okay. And yeah, it's very similar. It's very similar. But what we did yesterday was just the segment addition part. Today is the midpoint, which means they're going to be, those two parts are going to be equal. So it's kind of the same thing, but just a little different. And that's what happens a lot in this class. We do kind of the same thing over and over again, but we add like one part to it each day. Okay? So then you get 5 times 8 is what? 40. 40 plus 1 is? 41.
42.
6 times 8 would be 48. Subtract 7, you get 41. Does 41 equal 41?
No.
Yes. So that means you know that you did something correct. Let's try another one.
What is easy? 8x minus 6.
I think this is very similar to the one you were asking about with number 19 in the homework. I think this is very similar to that.
Well, I know what you
Hold on. When we do this, remember, write down what the definition means. If A is the midpoint of the whole segment, if A is the midpoint of the whole thing, that means these two parts have to be the same. So you write it down to force yourself to fill in the blanks correctly. That means, oops, let me write this. That means you have that. From there, you fill in the blanks. You fill in the information that you know. You know that 3x equals 5x minus 6. Now, this becomes one of those types of problems where people have an issue because notice on one side of the equation, there's just a 3x, there's no extra numbers. So when you move it, what goes there?
Oh, what?
No.
A 0.
Exactly. So this is also one of those styles of problems. You still have variables on both sides. You still start by moving them around, which means you have to pick on the little guy. In this case, again, the little guy is the 3x. So you're going to subtract 3x over to the other side. So 3x minus 3x leaves you how much?
0.
0. And you get that. What do you do with the negative 6?
You multiply it by 2x.
Nope.
Add 6.
You add 6 back to the other side.
You did the last time. I said that. 6 equals 2x.
And what's x then?
3.
What's that? Yes, sir. Good question. Back in the very beginning here, can you subtract the 5 just to bring it over? Sure. You get the same exact answer. The only reason that I don't do that, because you get negatives. You know what happens a lot of times when you guys have negative values? You forget that they're negative. That's why by moving the little guy, it kind of forces you to stay away from negatives. But if you're comfortable doing it, that's fine. You're going to get the same thing. You get negative 2x equals negative 6. Usually what happens is when people rewrite that negative 6, they forget to put the negative in. Divide out, you still get x equals 3. You get the exact same answer. It's a great question. Okay? All right. I'm not saying that there's always one perfect way of doing these problems, but what I try to show you guys is the way that I would set it up, so that way you'll be less likely for error, if that makes any sense. Okay? And then you have 3 for x. So then if you substitute back in, 3 times 3,
9.
5 times 3 minus 6, you both get 9s. Okay? Pretty quick. We put in the other ones there.
I'm going to pick up this easy part. But I'm not saying that really fell out. This is the home. That's what we got to do. The rope.
Take a minute.
Oh, no. This look too high.
Take a minute. So if you guys are all getting that point on 7 where things get a little weird, it's all right.
I got the
So
first one, though.
first one, real quick. We know that M is that midpoint. Guys, we know that M is the midpoint, so we just set those two parts equal to each other. Subtract the x. We get 20, 4x minus 4. You add 4.
Oh, it's a.
And we get 6. Okay? Yes, ma'am.
Why are we adding
What's that?
Why are we adding
Because we have what's the midpoint. Midpoint cuts the thing into 2 equal parts. That means those 2 chunks are going to be the same. All right? So now if 6 is x, they're asking you to figure out what AM is. Well, take the 6 and you substitute back in. What's 6 plus 20?
6 plus 20 is 26.
There you are. Okay. On the other one, same deal. We have the midpoint. M's the midpoint, which means these 2 segments have to be equal. That's why they throw the tick marks in there to show you. So when you do this, you get your 4x minus 12 is negative 2x plus 21. Again, we start by picking on the little guy. So we move the negative 2. How do you move a negative 2?
You add
Very good. So we add the negative 2 over.
add positive.
Yep, sorry, that's what I meant. So you add the positive 2 to both sides. You get 6x minus 12 is 21. Now, move the 12. What do you do?
Add.
You add it over. Good.
Maybe it's successful.
Okay. Divide it by 6.
Then you get some fraction. 5.5? How do you
Put in your calculator. You get 5.5, or it gives you a the fractional amount. I think it might actually say 11 over 3. No. I'm sorry, 11 over 2. And that's okay. Yes, ma'am. Yeah. Yeah, guys. Hey, ladies and gentlemen, it is, I'm just going to let you know now. Don't freak out if you get a decimal or a fraction for an answer. It happens. It happens a lot. Okay? It happens more and more and more throughout the year. It is completely okay. Don't think that you screwed something up when you start looking at, oh no, I didn't pass my own. You probably did just fine. Use your calculator. Okay? I forgot what this one asked you to solve. It asked you to find MR. So in your calculator, what you would do is you take your 5.5, you take -2 times 5.5 plus 21. Oops, sorry, I didn't realize. We moved this a little bit.
Did you have to buy that?
What? This? No, we did have to buy the emulator software for the computers, yes. So if I type that in my calculator, -2 parentheses 5.5 parentheses plus 21. A lot of times when I write stuff out, I write it out in such a way that you can enter it directly into the calculator and not have to worry about it. It'll work. And this will give you 10. Ooh. Okay. And that works.
I said 10. Is this the homework thing?
What's that?
So what do we got homework today?
Yeah, what I want to finish out then is going back to where we were at yesterday. Obviously, 19 wouldn't have worked. It should have been 17. So let's do this.
I did 19.
Well, good. Well, good. Then you have one less to do tonight. So what I want you to do is finish out. We have 19 then through 29 odds, and then 39 and 40. So you did this on Tuesday. This is tonight's. Okay. Page, it's the exact same page you were at yesterday. 24. Same stuff. Yes, sir. Yeah, that's fine. Absolutely. Just add to it. Please do. Like I was saying yesterday, we just ran out of time to finish up talking about midpoint, and I didn't think it was a big deal just to kind of stretch it in the second day. Not a big deal at all. I think what we'll wind up doing tomorrow, is we'll talk about angles, angle addition, and we'll be able to get into what's called angle bisectors tomorrow, because an angle bisector is the exact same thing as a segment, a midpoint, excuse me, but you're just dealing with an angle instead. So we should be able to get through both of those parts. And on Friday, we'll probably just have a little bit easier of a day to get through some stuff. Okay? Questions at all? Do you want to put it up on the board so you can take a picture of it, or you want to pull your Chromebooks up?
I'm sorry.
Or here. Ladies and gentlemen, if you want to take a picture, here's the textbook of mine. If you want to take a picture of it, of the problems, we'll just leave it right here for you. 24, and then they had to go over these 3 pages. All right?
Can I raise your hand?
Watch your